Hello students, welcome back in maths lecture. In earlier lecture, we seen two definitions, solenoidal vector and irrational vector, and we have seen each related example, and we also completed each related to theorems. So first of all, here we recall both the definitions. So what is called the solenoidal vector? As you know, divergence of vector function is equal to scalar quantity 0. Then f bar means our vector function f bar is known as the solenoidal vector, and if curl f bar is equal to 0 vector, then f bar is called the irrational vector. Now in this lecture, first of all, here we see one examples related to solenoidal vector. So note down the question. So question is say that if a vector function, you are given vector function f bar is equal to x cube z minus axyz, where your a is any constant, x cube z minus axyz I cap plus xy minus 3x square yz j cap plus yz square minus xz into k cap is a solenoidal vector. Then find value of a. तो मित्रों आपने क्वेश्चन में कीधुं छे आपणुं जे वेक्टर फंक्शन छे ए केवुं छे सोलेनोइडल वेक्टर छे. दैट मीन्स डाइवर्जेंस ऑफ f bar is equal to 0, and to find the value of a. So it's very easy to find the value of a, because we have already said in question our function is the solenoidal vector. That means divergence of f bar is equal to 0. So let's see solution. So first of all, here we write our vector function f bar. We have given x cube z minus xyz I cap plus xy minus plus yz square minus xz into k cap. Now we have given divergence f bar is equal to 0. મિત્રો આપણને ક્વેશ્ચનમાં કીધું છે આપણું ફંક્શન કેવું છે સોલિનોઇડલ ફંક્શન છે. ધેટ મીન્સ ડાયવર્જન્સ ઓફ વેક્ટર ફંક્શન f bar is equal to 0. So now we find the divergence of our vector function f bar. So divergence f bar, what is the formula? Del f1 upon del x plus del f2 upon del y plus del f3 upon del z is equal to 0, where our f1 is x cube z minus xyz, our f2 is xy minus 3x square yz, and our f3 is yz square minus xz. So here we doing partial derivative of f1 with respect to x, means આપણી જે ફર્સ્ટ ટર્મ છે એનું આપણે પાર્શિયલ ડેરિવેટિવ વિથ રિસ્પેક્ટ ટુ x કરી તો x ક્યુબ z નું થશે 3x square z minus axyz with respect to x કરીએ તો x નું થશે 1, here remain ayz, so ayz plus now we doing the partial derivative for f2 term with respect to y. આ ટર્મ્સ નું partial derivative with respect to y કરવાનું છે. so xy નું થશે here x minus 3x square yz નું થઈ જશે 3 as it is, x square it is, y નું થશે 1, remain z plus f3 terms નું with respect to z કરવાનું છે. so yz square becomes the 2yz minus xz નું થઈ જશે x. Now we just simplify is equal to 0. Now see, here we write is 3x square z minus ayz plus x minus 3x square z plus 2yz minus x is equal to 0. So 3x square z plus and 3x square z minus. Now plus x minus x also cut. So just remain two terms, minus ayz and plus 2yz. So now this term we can write as the implies 2yz minus ayz is equal to 0. Now take yz common in these two terms. Yz take outside, so remain 2 minus a is equal to 0. So મિત્રો બે ટર્મ્સ નું પ્રોડક્ટ અહીંયા 0 થાય છે, મીન્સ મલ્ટિપ્લિકેશન 0 છે. ધેટ મીન્સ આઈધર yz is equal to 0 or 2 minus a is equal to 0. So here we write as yz is equal to 0 or 2 minus a is equal to 0. Now to find the value of a, so our a is 2. So this is the solution of our first questions. Now next we discuss one theorem. So first of all, note down the statement of the theorems. For a scalar function, phi on D, prove that gradient phi is irrational vector as curl of gradient phi equal to 0 vector. So now statement of the theorem is say that for a scalar function phi defined on domain D, prove that gradient phi is an irrational vector. અથવા તો આપણે આ રીતે પણ પ્રૂફ કરી શકીએ. You can also ask in this form, prove that curl of gradient phi is equal to 0 vector. So meaning is gradient phi is the irrational vector. So as we know our definition of the irrational vector, curl f bar is equal to 0 vector, then f bar is called the irrational વેક્ટર. તો મિત્રો અહીં આપણે પ્રૂફ શું કરવાનું છે? ગ્રેડિયન્ટ ફાઈ ઇઝ એન ઇરેશનલ વેક્ટર. તો આપણે બતાવવું પડે કર્લ ઓફ ગ્રેડિયન્ટ ફાઈ ઇઝ ઇક્વલ ટુ 0 વેક્ટર. ઇફ વી પ્રૂવ કર્લ ઓફ ગ્રેડિયન્ટ ફાઈ ઇઝ ઇક્વલ ટુ 0 વેક્ટર, ધેટ મીન્સ gradient phi is the irrational vector. So you ask in another form, prove that curl of gradient phi is equal to 0 vector. That means to prove gradient phi is irrational vector. So let's see solution. So first of all, here we define our gradient phi. So let phi be any scalar function defined on domain D. So here we find the gradient of function phi. So as you know, what is the formula of the gradient phi? Del phi by del xi cap plus del phi by del yj cap plus del phi by del z into k cap. Now we find the curl of this gradient phi. Now curl of gradient phi is equal to, as you know, what is the formula of the curl? ijk del by del x del by del y del by del z. હવે મિત્રો અહીંયા આપણી ટર્મ્સ આવશે f1 f2 f3 કોણ હશે? our f1 is the del phi by del x, our f2 is del phi by del y, and our f3 is the del phi by del z, because here we find the curl of gradient phi. So that's why our f1 is del phi by del x, f2 is del phi by del y, and f3 is del phi by del z. So here we write as del phi by del x, del phi by del y, and del phi by del z. Now just simplify that. So del by del y into del phi by del z. So here del upon del y into del phi by del z minus del by del z into del phi by del y into I cap. चलो જે રીતે આપણે ડિટર્મિનન્ટ ફાઇન્ડ કરી છે તે આપણે ડિટર્મિનન્ટ ફાઇન્ડ કરીએ del by del y into del phi by del z minus del by del z into del phi by del y into I cap minus del by del x into del phi by del z minus del by del z into del phi by del x into j cap plus del by del x into del phi by del y minus del upon del y into del phi by del x into k cap. So now we are doing the partial derivative of our function del phi by del z with respect to y. So we can write as the del square phi upon del y del z minus this term del upon del z into del phi by del y can be written as the del square phi upon del z del y I cap minus del square phi by del x del z minus del square phi upon del z del x into j cap plus del square phi by del x del y minus del square phi by del y del x. As we know rules of partial derivative, del square phi upon del y del z is same as the del square phi upon del z dy. Means function phi નું તમે પેલા partial derivative with respect to z કરો અને એનું પછી તમે partial derivative with respect to y કરો. એનો આન્સર કેના જેટલો થશે? First of all doing the partial derivative function phi with respect to y and after that doing with respect to z. So both answer is the same. That means these both terms are the same. So 0 I cap. Similarly in second one del square phi upon del x del z is same as the del square phi upon del z del x. Similarly in third terms 0 k cap. So finally here we get 0 I cap plus 0 j cap plus 0 k cap, or we can also write as the vector 0. તો મિત્રો કર્લ ઓફ ગ્રેડિયન્ટ ફાઈ આપણને 0 મળે છે, 0 વેક્ટર મળે છે. ડેફિનેશન ઓફ ઇરેશનલ functions, if curl of gradient phi is equal to 0 vector, that means gradient phi is the irrational vector. So here we write as by definition of irrational vector, gradient phi is irrational vector. Hence proved. So this is the proof of our theorem. Let us recall one more times. Now to prove gradient phi is an irrational vector, that means to prove curl of gradient phi is equal to 0 vector. So first of all here we define our scalar function phi. So let phi be any scalar function defined on domain D. મિત્રો આપણી પાસે પેલા gradient phi હોવા જોઈએ. So as we know what is the formula of the gradient phi, del phi by del x I cap plus del phi by del y j cap plus del phi by del z into k cap. મિત્રો આપણે gradient phi મળી ગયા છે, એનો આપણે હવે કર્લ ફાઇન્ડ કરીશું. સો હિયર વી એપ્લાય અવર ફોર્મ્યુલા ઓફ ધી કર્લ I j k del by del x del by del y del by del z del phi by del x del phi by del y del phi by del z. હવે આપણા f1 f2 f3 કોણ થશે? del phi by del x del phi by del y and del phi by del z, because we find the curl of gradient phi and we just simplify its determinant. As we know del square phi upon del y del z is same as the del square phi upon del z del y. So this terms becomes the 0. Similarly in second term and third term. So finally here we get the 0 vector. That means curl of gradient phi is equal to 0 vector. So as a definition of the irrational vector, gradient phi is an irrational vector. So this is the proof of our theorem. Now next we will discuss Laplace operator. So Laplace operator is nothing but the dot product of two operator nebula. As we know how to define the operator nebula. Operator nebula is nothing but the del by del xi cap plus del by del yj cap plus del by del z into k cap, or we can also write as del by del x, del by del y or del by del z. तो આપણે જે ઓપરેટર નેબ્લા તો એ કોણ છે? એક વેક્ટર ક્વોન્ટિટી છે. નાવ વી ડુઈંગ ધી ડોટ પ્રોડક્ટ વિથ નેબ્લા ઇટસેલ્ફ. મીન્સ આપણે આ જે ઓપરેટર નેબ્લા છે એનું પોતાની સાથે ડોટ પ્રોડક્ટ કરીએ તો શું લખાશે? ઓપરેટર નેબ્લા ઇઝ ડેલ બાય ડેલ xi કેપ પ્લસ ડેલ બાય ડેલ yj કેપ પ્લસ ડેલ બાય ડેલ z k કેપ ડોટ પ્રોડક્ટ વિથ ઇટસેલ્ફ. ધેટ મીન્સ અગેન ડેલ બાય ડેલ x i કેપ પ્લસ del by del yj cap plus del by del z into k cap. Now we doing the dot product of two vectors. So as we know how to define del by del x I cap into del by del x I cap means del square upon del x square. I dot I થઈ જશે 1. હવે મિત્રો આગળ કઈ રીતે ડોટ પ્રોડક્ટ થશે? del by del x into del by del y. So here we write as the I dot I. Next multiplication થશે del by del x into del by del y means del square upon del x del y. I dot j. Next term is the del square upon del x del z into I dot k plus del by del y into j cap multiply with the del by del x into I cap. That means here we write as the del square upon del y del x j dot I plus del square upon del y square j dot j plus del square upon del y del z j dot k. Similarly del by del z upon k can multiply with all terms. That means del square upon del z square k dot I plus del square upon del z into del y k dot j plus del square upon del z square into k dot k. As you know I dot I થઈ જશે 1, I dot j 0. So here finally remain your terms are કઈ terms બાકી રહેશે મિત્રો? These terms means del square upon del x square I dot I 1 થઈ જશે. This terms 0, I dot j 0, I dot k 0. So this term is 0 plus this term is 0. Now j dot j is again 0, j dot j again 1. So remaining next term is the del square upon del y square. This term j dot k is again 0, k dot I 0, k dot j 0 and last term is the del square upon del z square k dot k is 1. तो मित्रों कई terms बाकी रहते हैं? Only remain the 3 terms. That means del square upon del x square I dot I1 plus del square upon del y square j dot j1 means and last is the del z del square upon del z square k dot k1. So finally here we get the dot product of two operator nebula is del square upon del x square plus del square y upon del y square plus del square upon del z square, and this nebula dot product can be expressed as nebula square, and this operator nebula square is known as the Laplace operator. So in short Laplace operator is defined as the del square upon del x square plus del square upon del y square plus del square upon del z square. So Laplace operator is nothing but the dot product of our operator nebula. So this nebula square is known as the Laplace operator. So now we define the definition of Laplace operator. So write down the definition of Laplace operator. As you know, nebula square is defined as the nebula dot nebula is equal to del by del xi cap plus del by del yj cap plus del by del z into k cap dot product with itself del upon del xi cap plus del upon del yj cap plus by del z into k cap. And what is the answer of this? Answer of this is nothing but the del square upon del x plus del square upon del y square plus del square upon del z square is called Laplace operator. Is called Laplace operator. So in short, here we write as the nebula square is equal to del square upon del x square plus del square upon del y square plus del square upon del z square. तो मित्रों एग्जाम में पूछाय define the Laplace operator. So write down the nebula square is equal to del square upon del x square plus del square upon del y square plus del square upon del z square is called the Laplace operator. Now we define the Laplace equation. तो मित्रों जे रीते આપણે પેલા ઓપરેટર nebula ડિફાઇન કરેલા હતા એના પછી હવે એનો ડોટ પ્રોડક્ટ વિથ સ્કેલર ફંક્શન phi સાથે આપણે ડિફાઇન કરીએ તો આપણી ફોર્મ્યુલા હતી del phi by del x I cap plus del phi by del y j cap plus del phi by del z into k cap, and this nebula dot phi is called the gradient. Similarly, here we define nebula square into phi. So this nebula square phi is known as the Laplace equations. So here we define the definition of Laplace equations. Write down the definition of Laplace equations. Let phi be any scalar function defined on domain D, and its second order derivative exists, then nebula square phi is equal to del square phi by del x square plus del square phi by del y square plus del square phi by del z square is equal to 0 is called Laplace equation. Laplace equation. So this is the definition of the Laplace equation. In short, nebula square phi is equal to 0 is called the Laplace equation. Now here we multiply nebula square with the function phi, and phi is the scalar function. તો મિત્રો phi કેવું છે સ્કેલર ફંક્શન છે, તો સ્કેલર ફંક્શન છે તો દરેક ટર્મ સાથે મલ્ટીપ્લાય થશે. ધેટ મીન્સ લખાશે del square phi by del x square, del square phi by del y square and del square phi by del z square. So keep in your mind this form. This form is known as the Laplace equations. તો મિત્રો તમને લાપ્લાસ ઓપરેટર અથવા તો લાપ્લાસ ઇક્વેશન પૂછાય ખાસ ધ્યાન રાખજો. જો લાપ્લાસ ઓપરેટર તમને કીધું હોય તો જસ્ટ રાઇટ ડાઉન ધ nebula square is equal to del square upon del x square plus del square y by del y square plus del square upon del z square. If you ask the definition of Laplace equation, then define in this way. Let phi be a scalar function defined on domain D, and its second order derivative exists. Then nebula square phi means del square phi by del x square plus del square phi by del y square plus del square phi by del z square is equal to 0 is called the Laplace equation. So in short, keep in your mind nebula square phi is equal to 0 is called the Laplace equation. Now we see its related examples. Now we discuss the example of the Laplace. So write down the question. Question is find nebula square f, that means find the Laplace of following scalar functions. You have given first scalar function is phi of x y z is equal to x square y plus y square z plus z square x. Second scalar function is 2x cube plus y square plus z raised to 4. So let's see solution. So in first one we have again scalar function phi of x y z is equal to x square y plus y square z plus z square x. So now to find the nebula square phi of our scalar function. So write down the first of all formula of nebula square phi. So nebula square phi, how to define? Del square phi by del x square plus del square phi by del y square plus del square phi by del z square. This is called the equation number 1. Now we find the value of del square phi by del x square, del square phi by del y square plus del square phi by del z square. How to get this value? Here we are doing partial derivative of function f of phi with respect to x. Next we are doing is again derivative with respect to x. That means we get the value of del square phi by del x square. આપણું જે ફંક્શન phi છે એનું પહેલા partial derivative with respect to x કરીશું. So here we get the value of del phi by del x. So what is the partial derivative of our function phi with respect to x? So here remain the 2xy y square z નું થઈ જશે 0 plus z square x માંથી મળશે આપણને z square. Now we are doing the second time with respect to x. That means we write as the del square phi by del x square. Again મિત્રો partial derivative with respect to x કરીએ. So 2xy નું થઈ જશે 2y, z square નું થઈ જશે 0. So final is the 2y. So value of del square phi by del x square is the 2y. Similarly here we find del phi by del y. Function phi નું with respect to y કરીશું. So x square y માંથી આપણને મળશે x square, y નું થઈ જશે 1 plus y square z નું થશે 2yz and z square x is constant, so it becomes the 0. Now we are doing with respect to again y. So del square phi by del y square is equal to x square is 0, 2yz માંથી થશે 2z. So final answer is the 2z. Now we are doing partial derivative with respect to z. So x square y નું થઈ જશે 0, y square z નું થશે 2 y square અને z square x નું થશે 2zx. Now we are doing with respect to again z. So del square phi by del z square is equal to y square નું થઈ જશે 0, 2zx નું થશે 2x. So final answer is the 2x. Now substitute all this value in equation 1. So here write as from equation 1 nebula square phi is equal to, what is the value of del square phi by del x square? 2y plus value of del square phi by del y square is the 2z and value of del square phi by del z square is the 2x. So this is the value of del square phi nebula square phi. So nebula square phi is equal to 2 into x plus y plus z, and keep in your mind this answer is the scalar function. તો લાપ્લાસ જે આપણે ડિફાઇન કરી છે એ હંમેશા કેવી ક્વોન્ટિટી મળે છે? સ્કેલર ફંક્શન મળે છે. સો લાપ્લાસ nebula square phi of this first question is 2 into x plus y plus z, and this is the scalar quantity. Try to find nebula square phi in this second one as yourself. In second one you are given 2x cube y square into z raised to 4. Try yourself, note down the questions. Now in next example we have given vector function in coordinate form x cube y cube z cube. Then prove that gradient of divergence f bar is equal to 6 into vector r bar. As you know what is the vector r bar? We already defined in earlier lecture as r bar is nothing but the our standard vector xi cap plus yj cap plus z k cap, and we define r is nothing but the under root x square plus y square plus z square. મિત્રો આપણે વેક્ટર r bar ને ઓલરેડી ડિફાઇન કરી ચૂક્યા છીએ. આ વેક્ટર r bar is our standard vector defined as the xi cap plus yj cap plus z k cap. So નાવ ટુ પ્રૂવ ગ્રેડિયન્ટ ઓફ ડાયવર્જ એફ બાર ઇઝ ઇક્વલ ટુ 6 ઇન્ટુ આર બાર. હવે આપણે ગ્રેડિયન્ટ ફાઇન્ડ કરવાનો છે, પણ કેનો ફાઇન્ડ કરવાનો છે? ડાયવર્જ એફ બારનો. તો પહેલાં તો આપણી પાસે ડાયવર્જ એફ બાર હોવા જોઈએ. સો ફર્સ્ટ ઓફ ઓલ હિયર વી ઓબ્ટેન ધી ડાયવર્જ એફ બાર. Next is solution. And as you know how to find the diverge f bar of any vector function. So first of all, every vector function is x cube I cap plus y cube j cap plus z cube k cap. Now we find divergence of this. Del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Our f1 is x cube and we are doing partial derivative with respect to x, that means 3x square. Our f2 is y cube and we are doing partial derivative with respect to y, that means 3y square. Our f3 is z cube and we are doing partial derivative with respect to z, that means 3z square. So this is our divergence. So divergence of f bar is equal to 3x square plus 3y square plus 3z square. હવે ડાયવર્જ એફ બારનો એનો હું ફાઇન્ડ કરવાનું છે, ગ્રેડિયન્ટ ફાઇન્ડ કરવાનું છે. સો હિયર વી ફાઇન્ડ ધી ગ્રેડિયન્ટ. એઝ વી નો હંમેશા ગ્રેડિયન્ટ કેનો મળે છે? સ્કેલર ફંક્શનનો મળે છે. સો નાઉ ઓબ્ઝર્વ 3x સ્ક્વેર પ્લસ 3y સ્ક્વેર પ્લસ 3z સ્ક્વેર ઇઝ અ સ્કેલર ફંક્શન. સો ગ્રેડિયન્ટ ઓફ ડાયવર્જ એફ બાર ઇઝ ઇક્વલ ટુ વોટ ઇઝ ધ ફોર્મ્યુલા? ડેલ બાય ડેલ એક્સ. હવે મિત્રો આપણે ફોર્મ્યુલામાં ફાઈ લખતા હતા, કારણ કે આપણે ગ્રેડિયન્ટ આ રીતે ફાઇન્ડ કરતા હતા. ગ્રેડિયન્ટ ફાઈ ઇઝ ઇક્વલ ટુ del phi by del x I cap plus del phi by del y j cap plus del phi by del z into k cap. જે આપણું સ્કેલર ફંક્શન હતું એનું પાર્શિયલ ડેરિવેટિવ રિસ્પેક્ટ ટુ x, પાર્શિયલ ડેરિવેટિવ રિસ્પેક્ટ ટુ y અને પાર્શિયલ ડેરિવેટિવ રિસ્પેક્ટ ટુ z કરતા. હવે અહીં આપણું ફંક્શન કોણ આપેલું છે? ડાયવર્જ એફ બાર. સો હિયર વી રાઇટ એઝ ધી ફોર્મ્યુલા ઇન ધીસ વે. ડાયવર્જ એફ બાર મીન્સ આપણું જે ડાયવર્જન્સ એફ બાર મળ્યું છે એનું પાર્શિયલ ડેરિવેટિવ રિસ્પેક્ટ ટુ x કરીશું ઇન્ટુ I cap plus del by del y diverge f bar into j cap plus del by del z diverge f bar into k cap. જે ડાયવર્જન્સ એફ બાર મળ્યા છે એનું પાર્શિયલ ડેરિવેટિવ રિસ્પેક્ટ ટુ x કરવાના છે. તો 3x સ્ક્વેરનું થશે 6x into I cap. Now we doing partial derivative with respect to y, that means 3x સ્ક્વેરનું 0 થઈ જશે, 3y સ્ક્વેરનું થશે 6y into j cap. અને વિથ રિસ્પેક્ટ ટુ z કરીશું. સો 0 પ્લસ 0 અને 6z. નાવ ઇન્ટુ k cap. નાવ ટેક 6 આઉટસાઇડ. xi cap plus yj cap plus z k cap. And this is nothing but our vector r. So 6 into vector r bar. This is our standard notation denote the vector r bar. R bar is nothing but the xi cap plus yj cap plus z k cap. So 6r bar. Gradient of diverge f bar is equal to 6 into r bar. So this is the solution of our these examples. આપણે પ્રૂફ કરવાનું હતું gradient of diverge f bar is equal to 6r bar. So first of all here we find the divergence f bar. After that we find its gradient, as we know how to find the divergence and gradient of any functions. So this is the solution of this example. Now today we stop here. In next lecture we will see some more examples. Thanks for watching this video. Thank you. Have a good all of you.